All right, guys. So this is the last one that I'll be doing with you guys. So this was a more complicated one. The other one was pretty simple and straightforward. But we're gonna do this crazy one that we did in class about a few days ago, I think last week. So we'll go ahead and read the whole thing, and then we're gonna look at what's important in this section. So Reed Haley, manager of the Dilbert Almond Orchards, is interested in determining whether to grow almonds or walnuts. So she needs to determine whether she wants to grow almonds or walnuts for the coming growing season. The cost of growing almonds is on his orchard for the coming year is estimated to be 200,000. Growing almonds, 200,000. That's going to cost him. So if it's going to be a cost, it's going to be negative 200,000. He estimates the cost of growing walnuts is only going to be 100,000. So this is growing walnuts, and it's going to cost him negative $100,000 because that's out of pocket. If almonds are planted, revenue generated for heavy rainfall season is estimated as 220,000. So we see almonds, right? If almonds are planted in heavy rain season, 220,000. Heavy, 220,000. These are just side notes that I'm writing just to help me out when I write out the whole tree diagram. The revenue for normal rainfall, so normal is going to be another category, is 300. We put normal, 300,000. And lastly, it's going to be the revenue generated for light rainfall is 220,000. So light is going to be 220,000. Oh, excuse me. So now what we're looking at is if walnuts. So I'm just going to put a circle on almonds, and now walnuts are planted instead of almonds. The revenue for heavy rainfall season is estimated as 80,000. So I'm gonna put walnuts here. Now I'm gonna put heavy. You know what I mean. And it's gonna be 80,000. So that's heavy, 80,000. Next is gonna be the average rainfall is gonna be 140,000. So just normal, it's going to be 140,000. And for the light rainfall, it's going to be estimated 70,000. Right there, 70,000. So what we're going to do here, and it still keeps going, the whole thing counts. The likelihood of a heavy rainfall season for next year is estimated at 0.2, which means 20%. So we put heavy for 0.2. Okay. Where is it? Heavy, 0.2. Average is going to be 50%. 0.5. And the last one's going to be light. It's going to be 30%. All right, and then you do the same thing here because they're the same thing. Okay, so now we have all our information, and now we're going to go ahead and do our chart. And these side notes are really going to help determine how we're going to do the diagram, because you're trying to just dissect all the important pertinent information here, and you're trying to put it all up in here. So we have a box, and that's our decision box. We like decisions, I guess. And we have two options. It is to grow walnuts, or let's grow almonds, or grow walnuts. And the cost of doing almonds is going to be 200,000, and the cost of walnuts is going to be 100,000. That's going to be the cost of what's, or that's how it's going to, the cost. And we have some information here. And so we have, if we were to grow almonds, we have, if it rains, if it's a heavy rainfall, revenue will be 220,000 for almonds. For average rainfall, revenue is going to be 300,000. And for light rainfall, it's going to be 220,000. And now we go here for the walnuts. So walnuts, if it's a heavy rainfall, from the information that we received here, all that goodie right there. Revenue would be 80,000. And next is going to be average. What we see here is going to be 140,000. Lastly, it's going to be light, which is going to be 70,000. And now, last information that we were given was the probability of it raining is going to be 0.20 for heavy, and you write the same thing over here, 0.20. And average was going to be 50, 0.50, 0.50, and for a light it was going to be 0.30, 0.30. So what we're going to do is we're going to actually multiply each and every single one of these and add them. So this is actually going to be two separate sections because we're trying to find which decision is best. So I'm going to go ahead and put a red line. And so that's decision 1, decision 2. And we're trying to determine which one's going to bring the most money. And so we have here 0.20 times 220, and then we have 0.50 times 300,000, and then we have 0.30 times 220,000. And you multiply these, you add them all together, and you're going to get $260,000. And that's what you're going to be putting in here. $260,000. And we do the same exact thing here. 0.20 times 80,000. 0.50 times 140,000. 0.30 times 70,000. And your total for that is going to be 107,000. And so you grab this number and put it in here. But we're not done. We actually have to subtract this number by this number. So because this is the cost of what it's going to do to produce this. And that's going to be 100,000 is going to be the cost of producing walnuts in the orchard. So the last thing you do is subtract 260,000 minus 200,000, which will equal $60,000 of expected return, and you have to compare it with 107,000, which we have this number. Subtract that number minus 100,000, and that will equal $7,000. Now you have to decide whether this one's better or this one's better. And of course we love more money, so we choose this to be the best option. So the best thing that Reed can do is, one, plant walnuts, or no, excuse me, plant almonds